Hello, my young and talented physicists. Welcome to class. In our last edition, we were able to explain in details the concept of latent heat, specific latent heat of fusion. We were also able to solve some calculation-related questions. As for today, we shall be looking at specific latent heat of vaporization, evaporation, and boiling. Your host, AJAYI Sunday, AINA. You all agree with me that if energy is constantly supplied to water, it boils when the temperature is 100 degrees Celsius. The temperature of the boiling water remains constant at 100 degrees Celsius as water changes to steam. If enough energy is supplied to the water, it changes to steam in a process known as vaporization. It is indicated on the diagram as water boils and the formation or the escape of the vapor. It is shown in the diagram above. Now, what are the learning outcomes for our class today? By the end of the lesson, you will be able to, 1, explain the meaning of specific latent heat of vaporization. 2, explain the concept of evaporation. 3, list 3 factors affecting the rate of evaporation. 4, explain why evaporation causes cooling. 5, define boiling and boiling points. 6, state how the presence of impurities affects the boiling points of a liquid. Then 7, which is the last one for the learning outcomes, explain the effect of pressure boiling point. So let's start by explaining vaporization. Vaporization of water occurs at a constant temperature of 100 degrees Celsius. The heat energy supplied as water changes to steam is not registered by the thermometer, and this is called latent heat of vaporization. What is specific latent heat of vaporization of a substance? It is defined as the quantity of heat required to change a unit mass of the substance from liquid at its boiling point to vapor without a corresponding change in temperature. That shows that as water boils at 100 degrees Celsius, it changes to vapor or steam still at 100 degrees Celsius. So the mathematical expression of this definition is quantity of heat equals mass times specific latent heat of vaporization. So by the time you make the specific latent heat of vaporization the subject of formula, then you have your Q equals your Q divided by mass. So our L subscript V is now Q over mass. What is the SI unit of specific latent heat of vaporization? It is joules per Kelvin. Now, having considered the meaning of vaporization as well as specific latent heat of vaporization, let's now discuss the differences between evaporation and boiling. Evaporation is a process in which liquid turns into vapor at a temperature below its boiling point. What are the factors affecting the rate of evaporation? The first one is temperature. The rate of evaporation increases with an increase in temperature. Then what of pressure? the rate of evaporation decreases with an increase in pressure. The third one is the area of exposed surface. The more the surface area of the liquid exposed, the more the rate of evaporation. The next factor is wind and dryness of air. The drier the air, the more the rate of evaporation. And this explains why our clothes dry faster during harmattan. The last factor is nature of the liquid. The lower the boiling point of a liquid, the higher the rate of evaporation. Volatile liquids such as ether at boiling point of 34.6 degrees Celsius evaporate faster than water at boiling point of 1 degrees Celsius. The next question that may be burning in our minds is why evaporation causes cooling. Why evaporation causes cooling? Just as I said earlier, volatile liquids such as ether, methylated spirit, or petrol cause cooling as they evaporate. If a little methylated spirit is spilled on the hand, it evaporates rapidly and the hand feels very cold. To change from liquid to vapor, the spirit requires latent heat, which is extracted from the hand. This consequently makes the hand to feel cool. From molecular theory, as more energetic molecules escape from the surface of the liquid, the average kinetic energy of the remaining molecules in the liquid is reduced, and the temperature of the liquid is therefore lowered. Hence, the cooling by evaporation. Let's look at the word boiling. Boiling or ebullition is the release of bubbles of vapor from the body of a liquid when its saturated vapor pressure equals the external atmospheric pressure. Then what is boiling point of a substance? It is defined as the temperature at which its saturated vapor pressure becomes equal to the external atmospheric pressure. What are the effects of impurities on boiling point? Impurities or dissolved substances in a liquid raise the boiling point of that liquid. Let's take for instance, when salt is added to food, it cooks faster. This is simply because salt is an impurity which increases the boiling point of water. At this high temperature of the water, food cooks faster than when boiled in pure water. What are the effects of pressure on boiling point? An increase in pressure at the surface of a liquid raises its boiling point, while a decrease in pressure lowers the boiling point. At high altitudes and mountain tops, liquids boil at a lower temperature than their boiling points due to a fall in pressure. At a depth such as the bottom of a deep pit or well, liquids boil at a higher temperature than normal boiling points. This can be illustrated in the diagram. Atmospheric pressure alters the boiling point of a liquid. When you consider the feet, you will discover that water boils at a lower temperature when you are at a high altitude or mountain tops. So look at it when it is below the sea level. the diagram indicates all that. Now, let's solve some questions using the formula specific latent heat of vaporization equals Q over M. The first example we shall consider is this. Example 1, all the heat generated by a current of 2 amperes passing through a 6 ohm resistor for 25 seconds is used to evaporate 5 grams of a liquid at its boiling point. What is the specific latent heat of vaporization of the liquid? As you can see, the parameters given are the current is 2 amperes, the resistor is 6 ohms, the time is 25 seconds, and the mass is 5 grams. The mass has to be converted to kilogram. What do we do there? We divide 5 grams by 1000 and we end up having 0.005 in kilogram. Then using the formula I squared RT equals ml subscript V. Then by the time I use the LV, make it a subject of formula, I'll have I squared RT divided by M. Substituting all the values into that formula, we have 2 squared multiplied by 6 multiplied by 25 divided by 0.005, and we shall have this answer, that is 120,000 joules per kilogram as the specific latent heat of vaporization of that liquid. Now, let's look at these self-assessment exercises. The first one is define specific latent heat of vaporization. The second one is differentiate between evaporation and boiling, just as we have discussed in the course of the lesson. In conclusion, evaporation causes cooling. Cooling by evaporation is used in the working of refrigerators,